how could you? All right, here we go. So derivatives of trig functions. That's the last little bit we covered on your quiz. Here are your respective trig functions. If you have sine, the derivative that is cosine. If you have cosine, the derivative that is a negative sign. Okay, it is a negative sign. And then the derivative of tangent is 1 over cosine squared x. Okay, 1 over cosine squared x. And then you pretty much use them just like how you would anything else. So we're going to take a look at a few examples. We'll do a few others. We'll even work with some of them in writing the equations as well, hopefully before the bell rings. Okay, so this very first one, we'll find the derivative of f of x equals sine x plus cosine x. Just like before, when you had terms being added together, you just take the derivative of each one. So what's the derivative of cosine? Sine?
Cosine x.
Cosine x, and the derivative of cosine?
Minus sine x. Minus sine.
Oh, wait.
It's gonna be that minus, because it would have been that plus a negative sine x, and so then that would be your derivative. Okay? That's like your most basic one. Okay? Over here, with this one, y equals cosine t squared.
Chain rule.
It is a chain rule. Okay, you have two functions here. What's your outside function?
Cosine x.
And what's your inside function?
T squared.
Okay? So remember with chain rule, you take the derivative of the outside with respect to the inside. So what's the derivative of cosine x?
Negative sine t squared.
It'll be negative sine x, but instead of putting an x, we're going to put the inside function, and then we multiply that by the derivative of the inside function.
So negative 2t.
See, you trying to jump step. What's the derivative of t squared?
Negative 2t.
Yeah, why
I mean, I'm going way down.
He's jumping steps. It would be a positive 2t, and then our final answer would be a negative 2t sine t squared.
You have to remember the rules.
Yeah.
Because those rules aren't in the book.
I don't believe chain rules in this.
Well, not the chain
Yeah,
rule,
this
the
one.
like that sine is cosine x and cosine.
I'm not quite sure. Yes.
Will we ever have to do like derivatives of like double integral?
It's possible.
Oh.
Because I mean think about it. Look at like a sine 2x. Look at that trig identity. That's nothing but what?
Product.
No, chain rules in here, but it's written all funky.
Okay.
What are the cosine rules?
So basically this is basically product rule.
Nice.
So
Oh, but she's saying that it, like they have sine x equals cosine x, and cosine x equals negative sine x.
and tangent.
Tangent x equals 1 over cosine squared.
Alright, so then you're good. You don't have to worry about memorizing them, okay? Just gotta make sure you know how to use them. Let's look at this one. We have 1 over tangent x. We got 1 over tangent x. How will we do that one? Yep.
You would have a double fraction where you go 1 over cosine squared x. I did the flip and then cosine squared x.
No.
No?
Got to be careful about that.
Do we have to? Does tangent also equal sine x over cosine x, and then you flip that thing over so it becomes cosine x over sine x?
No.
And you change the
Well,
thing
we
up.
have-
So it'd be sine x over negative
Yeah,
cosine.
you had to
Wait.
get a chain rule question.
You wouldn't be able to do it where you just take the derivative of the bottom and work that way, because this is a fraction. You either would have to do make it a negative 1, or you would do quotient rule. Either way would get you there. So if you did it as tangent x raised to the negative 1, then you'll have chain rule.
Wait, you can do chain.
Yeah, you definitely do
Because
chain
what
rule if
we
you
have-
did it this way. If you did quotient rule, it would just be quotient. And you work that way.
How would you do chain rule?
So what are our two functions? We did chain rule.
1 over x and then tangent x.
It'd be x to the negative 1 and
Tan?
tan x would be your inside function. So what's the derivative of negative x to the negative 1?
Negative
1 x squared.
Same thing.
X to the negative 2, what's going on? What's
Tangent.
and then you multiply that by the derivative of the inside, which is
1 over cosine squared x.
and so then you just make that back to positive and multiply, so you'll have a negative 1 all over tangent squared x cosine squared x.
Wow.
Yeah, that's negative 1.
Because it was a negative here.
I'm saying, where did that come from?
When you brought down the exponent in front. So this right here started the derivative, this part. So you brought it down, and you subtracted 1 from the exponent.
Oh, so we took tangent x and plugged it in to the x and then.
Look here in F.
We gotta change with D.
It is chain rule, but it's a double chain. Okay, realize that this problem can also be written like so.
I like it better like that.
Okay, and honestly, and you can do this. Okay, you're basically cubing the sine 2x function. And by doing this, you'll be able to see that okay, I have my 2 functions. What's my outside function?
Sin x3.
Not quite.
Just x cubed.
It would be just the x cubed, and then what's the inside function?
Sin x, right?
Sin 2x.
Change
Oh, there's
yeah.
2.
This is a double. So your outside function is x cubed, your inside function is sine 2x. So then you take the derivative of the outside, which is,
3x squared.
but I'm not going to put an x, I'm going to put a,
Sin 2x. Double ident.
and then I multiply that by the derivative of the inside. Now the derivative of the inside is yet another chain rule. What's the outside function?
Sin x.
And the inside?
2x.
So then what's the derivative of the inside?
Negative cosine.
Positive
Cosine squared.
Cosine x, but instead of putting an x, I'm going to put a,
2x.
and then I have to multiply that by,
2. So it's gonna be 3.
so our final answer is going to be 6, because you get 3 times 2,
Sin 2x squared.
sine 2x squared,
Cosine 2x.
cosine.
So it's 6 times square.
Because that will still be the square. And whether you put the square in between the sine and 2x or on the outside of the 2x, it'll still be 7.
So where does the times 2 come?
Because remember, when we take the derivative of this sine 2x function, it's another chain rule, and we have to take the derivative of the inside, which is the 2x.
So all you really do is just multiply the times 2.
Yep, let's say S6. There you go. So you can use trig functions with the other ones. Alright? Let's look at one with an equation. I'll just be practice for you guys. No, no. Alright. Let's look at this one. It says find the equations of the tangent and normal line to the curve at the point where x equals pi over 9.
It's pi over 9.
20 degrees.
Okay.
Alright? Now realize that, remember, how do we find the equation? How do we find the equation? Derivative.
Find the derivative.
And the opposite reciprocal.
Find the derivative,
I'll then find the slope of tangent line and the opposite reciprocal to get the normal line.
find the slope by plugging in what?
The what, x.
The x value. That will give you the slope of the tangent line, and then to find the slope of the normal line, it is the
Opposite reciprocal.
opposite reciprocal. Now there is one piece of information that we don't know to actually write the equation, and what do we not know? The y coordinate. We know the x, but we don't know the y. So how do we find the y coordinate? Plug it into the original function, and you got to know your unit circle, because what's 3 times pi over 9?
Pi over 3.
And what is the cosine of pi over 3?
And it's 60, so that's, square root 3 over 2, right?
1, 2, 3, so
Half.
it's 1 half.
It's 1/2. So my y coordinate is 1/2.
Yeah, because the cosine's small. and
I'm
it's
still
only
writing
1
this
half.
down.
We gotta find the derivative of cosine 3x.
Negative something, or would you?
It is chain rule. What's my outside function?
Cosine.
Cosine x.
Am I inside?
3x.
So I do the derivative of the outside, which is
Negative sine x.
But I'm not gonna put an x, I'm gonna put a,
3x
and then I have to multiply by the derivative of my inside.
3.
So there's my derivative.
Plug the x in.
To find my slope, I plug in the x.
If it becomes like this, you'll
Sine,
have
Very possible.
Square root of 2 times 3.
3 times pi over 9 is?
Pi over 3, the sign of that is root 3 over 2.
Also gets to bring you to.
So you plug in pi over 9, and you simplify using your unit circle to get root 3 over 2. And this right here, this negative root 3 over, this negative 3 root square root of 3 over 2 is the slope of your what?
Normal, tangent.
Tangent. To find the slope of your normal,
Then you have to multiply by root 3 because you can't have the on the bottom.
you have to multiply by root 3 to rationalize. So what will that give you?
2 root 3 over 6.
2 root 3 over 9.
Over 9. Root 3 times root 3 is
Positive.
3.
3 times
3 times 3 is 9. So then you can write your two equations. You should always default to which way?
Twice slope.
Unless they tell you otherwise.
They did it on.
So there's the slope of your tangent. There's the, not the slope, there's the equation of your tangent, the top